This video is of a 8-day movement that you occasionally see on eBay, and I haven't found much information on these other than finding the patent on Google Patents using the number that's given on this dial here. But this video will show a little bit of information that I know about these movements. And here is one of the movements. I happen to have two. One is not in as good a condition as the other. This one hasn't been cleaned. This one's been partially cleaned. This one has the original hairspring. This one came without a hairspring, and I used a hairspring out of a Waterbury 30-hour alarm clock. The rate isn't quite right, but it made it run. And when you see these, they have a very unusual mechanism. That the time train is conventional. The strike train, however, isn't really a strike train. There's a count wheel, but it only has 3 notches. They're spaced 120 degrees apart. And on the back side of the strike train is a square. And most of the time these movements show up without the rest of the parts. And the rest of the parts consist of a switch, a dial, which this is the dial that came off of this cleaner looking movement over here. I have some hands here, a terminal strip that goes with the switch, and a hand washer. The most important part is this brass square drive assembly that goes between the strike main arbor and the square on the switch. Now this switch is kind of odd. It's made by AH&H, Arrow, Hart, and Hagerman, and that's actually how I found this movement on eBay that was complete with the switch, the terminal strip, and the dial, was after doing a Google search for AH&H. And then about a year later, this one here has an inoperative strike mechanism, though. There's a tooth missing on the strike grate wheel, and the spring is broken, and the click is also broken. I suspect the spring breaking had a part to play in those events. This one I found about a year after this first movement, and it was very filthy. A little bit of time with some carburetor cleaner got it cleaned up well enough. The trippers on these dials here, see there's 3 trippers. They go around, they trip this mechanism here, and it warns, and then it will run, and it will sit there much like a conventional count wheel striking mechanism. It does 25 or sometimes 26 counts between notches. There you go. And then this would have, through rotating 120 degrees, would have, through rotating 120 degrees, operated this 3-position snap switch. And this 3-position snap switch, it switched kind of funny. There's three terminals here, and no one terminal is ever disconnected from anything. I think in one position it makes this one and this one, in the other position it makes this one and this one, and in another position it makes this one and this one. I might be wrong on that. It's been a while since I've sat down and traced it out. But as best as I can tell, this is an ordinary, of the period, an ordinary wall-mounted snap switch. It's just that instead of there being a black black Bakelite or plastic turn piece here, there is a square adapter screwed on to the shaft of the switch. It's all original. I don't know how original this terminal switch would have been to the whole apparatus. So, this is going to be kind of hard to do holding a camera. Let's see if I can set the camera down. So this whole thing would have gone together. Let me turn the view screen on. Well, let me turn the view screen on. Alright, well anyway. You could pretty much figure this out though. When putting this together, you would have had to have set this up to where everything was in sequence. But anyway, if you see one of these on the internet for sale or at a garage sale or who knows, that's what it is a timer operated switch mechanism. Let's see if I can operate the switch once you can see it. It's got a good wind up on this spring here. There we go. Now, this terminal and this terminal are closed and this terminal is open. Operate it again. Anyway, it's probably not a good idea to run that strike mechanism without this switch load connected to it, because that spring isn't, the strength of that spring isn't sized for just operating that gear train. It's also sized for operating the switch mechanism. Now all three contacts are connected together. This one here is made to that one, and this one here is made to that one. There's only one more position in the switch left. Let's go ahead and operate it. See, it requires a fair bit of... Hold on, do this not looking through the viewfinder. Requires a fair bit of force. You can't really twist it very easily by hand. Alright, one more. What do we got here? This one is open to the other two, and this one are made. So there you have it. And the whole thing was designed. There's no way, in the way that this operates, there's no way to make it only trip, let's say, you know, twice in 24 hours. The thing is designed, it will always trip 3 times in a 24-hour period. So this switch will go through all three of its positions. This switch will go through all three of its positions in a 24-hour period, driven by that striking mechanism there. Like I said, the spring in this, and this is actually a slightly narrower spring. I haven't had these barrels apart to see what size the springs are. There's the time barrel there. I'm thinking these movements are made by either Seth Thomas or Waterbury. Judging from the patent date on Google Patents, it was, I believe it was 1914 was the patent date. From what I know of the major American clock companies, Seth Thomas and Waterbury, were the last two companies to switch over to a pin pallet escapement on their lever escapement clocks. And as you can see very clearly, well, limitations of this camera, I can't adjust the zoom or the focus on the fly making a video, but I think you can see, there you go. You can see rather clearly enough that that is a ratchet tooth lever escapement. Waterbury was quite well known for making movements for other makers for all sorts of different purposes. So they even adapted one of their 30-hour alarm clock movements for use as a phonograph motor for driving a cylinder phonograph for the, I believe it was the Emmett phone. Waterbury also adapted a movement. It looks like from the photos I've seen they adapted a 15 or a 30-day business movement for use as a phonograph motor for Edison, for the early Edison home machines. So it would not surprise me at all if Waterbury was the one who supplied the movements for this interesting switch mechanism that you see here. Watch this strike train once again. It's not really a strike train, is it? It's a switch train, right? So here we are. And these trippers, before I start this, these trippers would have been moved very slowly. Just the back side of this assembly there. There's the hour wheel. And then this wheel here is made fast with this dial that carries the trippers. So these trippers would have been rotating very slow indeed. Much slower than because in a conventional 8-day clock, such as this old Seth Thomas here, this is not to get too far off the subject here, but since I looked at it, this is a Seth Thomas college clock. This is the Yale model. It was a parts clock I picked up dirt cheap. The cabinet was mostly missing, but the movement and the alarm and everything else are complete. That's just a generic parts house pendulum. On one of these clocks, on a conventional clock, the strike train is activated by the minute arbor, which, as you know, makes one revolution every hour, so it's moving quite quickly compared to this, which each of the three trippers is activated once in a 24-hour period. So I'm speeding this up quite a bit. So there would have been a period of perhaps hours between a warning run and then when the train was released. So here we go. It's worn. There it is. On this movement, I've run it, I've counted, I think it's not very precise. It'll count 25, 25, and 26. Meaning to build some kind of a case where I can mount all these things together and operate it. After I get this movement, I'll take this movement I have not had apart. This one I have. I've just cleaned this movement enough that I can run it occasionally. It's what is today? Friday. It's 5 days into an 8-day run. So I wound it last Sunday. The striking mechanism here, I keep saying the switch mechanism, I have not wound more than about half. This click has a crack in it in much the same manner as this click here probably had a crack in it before it broke. So I'm going to have to, and as you can see, this click, the clicks here have screws holding them, where this one here has rivets. So this one's been, both of these clocks have numbers scratched into them that they've been worked on by repairmen with National Association of Watch and Clock Collector membership numbers. Anyway, this video has been long and rambling. I'm going to go ahead and cut it off. I'm about out of video space on the camera, so this is OK Bridges. And these are two very interesting clocks.